brackets f of x plus f dash of x dx. And in this module, let's take a very interesting question. Now the question says integral of log x minus 1 upon 1 plus log x square the whole square dx. Now my dear students, let's assume this to be our integral I. Now from the question we understand that we have a function of log here, a function of log, and there is no e raised to x present. So in such a case, we know how do we go about it. We know that we will substitute log x as t. We have seen that. We also know that it is important. So let us go ahead and write let log x is equal to t. If log x is t, can I say x is equal to e raised to t? And likewise dx is equal to e raised to t dt. So the given integral will look like, can I say t minus 1 upon 1 plus t square the whole square into e raised to t dt. Correct? Now my dear students, how do we simplify further? Now can I just separate the square? Let us write in the next step the integral equal to e raised to t into bracket t minus 1 the whole square upon 1 plus t square the whole square and a dt. Now my dear students, if I have to simplify further, it is pointless opening the brackets in the denominator. What we will do is, we will open the brackets in the numerator. In the process, we will get two terms in the numerator which are seen in the denominator, and they are t square and 1. So we can express the numerator in terms of denominator. So let us apply a minus b the whole square. So we will get e raised to t into t square minus 2t plus 1 upon 1 plus t square the whole square and a dt. Now if I group the terms as t square plus 1 together in the numerator, my next step will look like integral of e raised to t into brackets or into t square plus 1 minus of 2t upon t square plus 1 the whole square dt. Now my dear students, let us separate. In the next step, can I write it as e raised to t 1 plus t square upon 1 plus t square the whole square plus of minus 2t upon 1 plus t square the whole square and a dt. Is that okay my dear students? So let us copy this step. So in the next step, if I have to write, I can write e raised to t into brackets. Can I say 1 plus t square in the numerator and 1 plus t square in the denominator cancels. So effectively I am left with 1 upon 1 plus t square and plus of minus 2t upon 1 plus t square the whole square dt. Correct? My dear students, now if we take f of t as 1 upon t square plus 1, then the derivative will be minus of 1 upon t square plus 1 the whole square into derivative of t square plus 1, which is nothing but 2t. Or can I say the integral we have right now is of the form e raised to t into brackets f of t plus f dash of t dt. Correct? So as per the formula, it will be nothing but e raised to t into f of t plus c. That is e raised to t. F of t is 1 upon t square plus 1. So e raised to t into 1 upon t square plus 1 plus c. Now my dear students, the question was in terms of x, and very well if I can write, I will write e raised to t as nothing but x and 1 plus t. T was nothing but log x. So let us write the answer as x upon 1 plus log x the whole square plus c. No further simplification, and that's your final answer. Now my dear students, let us see what is there. This is the sum I need to practice on the same lines. Okay? Now let's take one entrance question. The question says integral of sine log x plus cos log x ds is equal to how much? Again my dear students, if you observe, you have a function of log. Therefore we need to substitute. So let us see the solution. Log x is there in the sum, and we have seen similar sum earlier also. So let us put log x is equal to t. So the integral will look like sine t plus cos t into e raised to t dt. I am not writing those steps because we have seen that for quite a many times. Now can I say the integral is of the form f of t plus of f dash of t dt? Correct? So if this is the case, f of t is sine t. So can I say the answer will be e raised to sine t, e raised to t sine t plus c? Now if it is e raised to t sine t plus c, can I say the correct answer is option C. In place of e raised to t, I will write x, and in place of t, I will write log x. That is option C. That's all we have in this module. Thank you very much.